extra essentials that are included, like spring and screen change to overhaul. Toledo Transkit even includes loose valve body gaskets that fit all 19 bonded separator plates. At Seal Aftermarket Products, we don't just make kits, we make kits better. Ask for Toledo Transkit by name.
Okay, moving right along. If you have any questions or comments, please send an email to webinars@atra.com. If you have any questions during the presentation today, please feel free to text them into the question box at any time, and we'll get those questions answered straight away. Here's our upcoming webinar schedule for the year. Bringing new training you can count on, delivered right to your shop. We've got reprogramming coming up later on in a couple of months. I've got the follow-up to this introduction, which will be the 6F35N internal show. We've got 3 in March, we've got 3 in August. I'm telling you, we've got a great, diverse package here for you guys. Diagnostics later on in the year. Reprogramming, as I said, we've got some 68 RSC, internal and intro. Just be sure to make the webinar and get your training right here. Okay, for you guys that might want to travel to Paris, Las Vegas Hotel, Paris Hotel in Las Vegas, it's never too early to start planning. October 27th through the 30th this year. It's a new location for this year's 2016 edition of the Powertrain Expo. Okay, here is the list of vehicle applications for the 6F35N. There's a ton of them out there on the road. So if you haven't seen them, you will. The Fusion, for one example, 1.5 liter covering all models to the 3.0-liter V6. So the Transit Connect is the small delivery vehicle, and so it comes in a quite a large offering of Ford and Mercury vehicles here. Short description: it's got a lockup converter. It's like all the rest of the Ford products do. 3 planetaries and 5 applying clutches, 5 clutches to get 6 speeds. The most notable difference between the 6040, I must say first that the 6F35 and the 6040 are identical on the inside and in their operation. However, there are no interchangeable parts. The planets are different, the ratios are different, but the external note is that the 6F35 is the computer outside the transmission, whereas the 6040 has the TCM bolted to the valve body, which we refer to as a TECM. Okay, in the parentheses down there at the applying clutches, we've got 1, 2, 3, 4. 3.5 reverse. That's the GM designation for those clutches. I kind of like it because it takes out the guesswork of when that clutch is applied. Yeah. Hydraulic system. We've got a valve body and a solenoid body, a main control and a solenoid body, a little bit different this year, and 7 solenoids that control the shifting and line pressure and lockup. The electronic system covers the shift timing, the line pressure, and the converter clutch. Just like most of the systems we become familiar with, the ignition, the electronic ignition system puts the crank sensor to the PCM. Well, it's part of the PCM, but that's where it gets the crank sensors from the EI system. And of course, that's most important in upshift and TCC timing. This has a redundant system, and it has a APP and a TP sensor. They are all drive-by-wire, so this gives a bit of redundancy here. If the APP goes bad, you'll still have upshifts, but you'll have harsh upshifts and harsh engagements. Same with the TP sensor. Of course, the PCM's the boss of the operation. The transmission range sensor, this is like the torque shift or the 5R110 range sensor. It's a 3-wire duty cycle switch. The PCM is expecting a fixed frequency duty cycle for each of the various positions. If it doesn't see what it's expecting, it'll code up. And we've got the ranges down. We've got the ranges here, and what they call fixed is a pretty good spread for park. We've got 8 to 25% duty cycle in park, and that duty cycle increases and the spread decreases as it goes towards low. Now, it's going to be important to look at these numbers on your scan tool should you have engagement problems, may even cause some shifting issues, or trans-range sensor codes. And of course, we've got the traditional brake pedal switch, position switch, and the turbine shaft speed sensor and the output shaft speed sensor as inputs for TCC control and shift timing. Let's see, here's our solenoid operation chart. We've got, across the top, we've got shift solenoids A, B, C, and D, which they call variable force solenoids. I used the term pulse width modulated early on. This is the Ford notation is for them to be called variable force solenoids. Shift solenoid E is a normally closed on-off solenoid, and the TCC solenoid is also a variable force solenoid. By the chart here, we can see that lockup is on in 4th, 5th, and 6th only. This goes for all models. And we can also see that 5th gear is fail-safe. All solenoids are off. Where this is good to know is that we can unplug this transmission. Say we were getting soft engagements, and as a quickie test, we'll unplug the transmission, start the car up, unplug it, and see if it starts banging into gear. It will go to a fail-safe high line and 5th gear. It will also have reverse. You should have reverse and 5th gear unplugged. There is no fail-safe to neutral on this unit. So it's a good quickie diagnostic tool. Here's the clutch apply chart. There again, in parentheses, this is the GM notation for these. I like to keep these in these. This was a Ford publication, but they kept them here anyway. And I like them because we can tell what ranges they're in very quickly at a glance. The low and reverse is complete. Low and reverse clutch is complete, especially in the drive ranges, is completely controlled by the TCM or the PCM. I'm sorry, based on the loads. It's on a launch from a stop, but it turns off after 5 miles an hour, and does not need to be applied. Does not need to be applied as we coast down to a stop, because that eliminates any chance of downshift feel. That, quite frankly, the low and reverse clutch does not have to come on a takeoff at any rate, because it's launching on the vehicle launches on the one-way sprag. They just put the clutch on to back up the sprag for more longevity. Here's a ratio chart for you guys. You can see that this thing's got a very low first gear ratio, 4:5 to 1, and 6th gear is our only overdriven ratio at 0.746 to 1. Here we have a shift speed chart for you guys. We've got a 2.5 liter and a 3.0 liter shift speed chart. And where these charts, these are pulled from the manufacturers. These are pulled from the manufacturers' information. So where these come in handy is, say we have a customer that has been driving a transmission into the ground, and they've been driving it so long that they can't remember what it shifts like. And so now we get the car, and we get it back into shape, gone through the transmission, and now we hand it back to the customer. They come back a couple of days later going, what's up with my car, and why does it shift so late? Or why does it shift so soon? Well, it's because they're not familiar with how it worked when it was brand new. It's been so long ago, or it's a used car, what have you. But the point is that you can bring out these shift speed charts and say, hey, look, you know, you're driving at a medium throttle here. We would expect you to be somewhere between 27 and 43 kilometers an hour on the upshift, which would be completely normal. Or as you get in further down the chart, all the way to, you know, 5-6 shift at 135 to 177 kilometers. Now, say you have a particularly brick-footed customer who comes in and says, gee, I think my transmission's slipping late at 51 to 66 kilometers an hour, when it's completely normal. What they don't understand is that the engine's screaming and it sounds like it's going to fly out the hood. I don't understand those kind of drivers, but they're definitely out there. And I always get a kick out of these heavy throttle shift speed charts, because they have a listing for the 5-6 upshift at 201 to 245 kilometers an hour as a normal upshift speed for full throttle. Now, first of all, around here there aren't too many places where I can go that fast, let alone do it that fast in a Ford Fusion with a 2.5 liter transmission. I don't think I'd trust any one of those cars to go 200 to 245 kilometers an hour. That would be a little bit scary. Anyways, the point being is, for the 3.5, for the 3.25 and the 3.0, we've got this column here that if a customer, it's more of a customer relations tool where they're not sure, and here you could hand it to them and say, look, this is what the dealers say, this is what the OE says, so where your car should shift at, and so they're happy with that, and off they go. Torque specs, we're real sticklers about torque specs, between 80 and 90 inch-pounds for the main control halves. Always a good idea. The main control to the case is about 90 inch-pounds or 10 Newton meters. Always a good idea. We like to have those. The main reason we want to take the time to set all of those bolts to the same torque is to make sure the pressure is equal all the way across the valve body and prevent warpage. Okay, solenoid body strategy. This is getting to be more important every day. We're starting to see this on all of the later model Ford products, that they've got these strategies. Now you want to make sure that your 13-digit solenoid strategy number and your 8-digit solenoid body ID number matches what's in the scan tool. If that does not match, when you go to put this thing back together, you're going to have some shift issues and a serious decrease in the longevity of the transmission. All right, here we see the location of the solenoid ID number, the 8-digit, and the strategy 13-digit number that's on the plug right here. I've flipped it upside down for you guys so we can see the numbers more clearly. Keep in mind, this is not a TCM on a Ford product. This is a contact plate only. You see the wiring loom here for the trans range sensor, and a pathway here. The speed sensor plugs. The speed sensors plug in right here. Also incorporates the TFT on the contact plate. So we're going to change the solenoid body. I'm not going to go through the step-by-step process here, but just know that when you get a new valve body, you're going to open up your laptop and go into the programming, hook up your J2534 connector, and get ready to program in the new strategy, 13 strategy 8-digit ID numbers into the main control. PCM, sorry. So that'll identify those numbers. You go to the Motorcraft website, download the file, and put it onto the PCM. It's very important once that is done. Once that's done, we want to, number one, put on the sticker that came with it so the next guy knows what's inside there. And number two, to get that car on the road and perform the adaptive drive cycle before delivering it to the customer. Because we've got to drive it through the adaptive drive cycle, or else you're going to give the customer an erratic shifting vehicle with possibly the possibility of some drivability concerns, and we don't want to do that. And to the end of using a laptop to reprogram, I just want to say quickly that I believe that all my attendees here should have that capability right now, and we are having a couple of reprogramming webinars in the next coming year. Laptops are just too cheap, and the software is just getting so reasonable these days. There's no reason not to hand over profit to the guy that comes around and reflashes, or taking it up to your local dealer. So that's enough on that subject. So anyways, it's very important to make sure that the solenoid strategy is logged into the PCM. Basically, what we're talking about is marrying the solenoid body, valve body to the PCM. And speaking of the solenoid body, here's our solenoid identification. You can see I've taken my engraver and engraved the numbers on the solenoids and engraved the numbers on the solenoid body itself on the aluminum casting right here. And this way I could take these solenoids out and pile them up on the bench, clean them all up, and put new O-rings on them to reuse the solenoids if things aren't damaged beyond repair. And that way I can make sure that they get back in their proper bore that they came out of. You do not want to mix up the normally open and normally solenoids. I haven't had anybody do that yet, but should you find that happens, send me an email, send us an email and let us know how that goes. Okay, our normally open solenoids are our line pressure control solenoid, shift solenoid B, and shift solenoid D, the green solenoids. You see the chart down at the bottom of the page. Low current, the seat on the left is off, and it allows pressure to solenoid feed circuit pressure to come in and flow to the clutch regulator and latch valves. Those are the valves that direct line pressure to the clutches. And on the right here, we've got high current. Now the solenoid feed circuit is blocked so that we have low pressure going to the regulator valves and to the pressure regulator lineup. The PR valve is and excuse me, boost circuit is controlled by the solenoid, the LPC, the line pressure solenoid right over here. So high current, low pressure, low current, high pressure. Now exactly the opposite are shift solenoid A, the TCC solenoid, and the shift solenoid C. So when the low current has got when the solenoid's off, it's blocking fluid down here on the left. On the right, the high current opens up the solenoid so that it regulates the clutch valves and the latch valves, and also the TCC valves. See, what we have here, when we have these normally open solenoids, the line pressure control and shift solenoid B, they're flowing max fluid. And what that means is that the B and D respective clutches are on and we have max line pressure, and that's what allows us to get that fail-safe mode. Okay, here's the shift solenoid E. This controls the clutch bypass valve. What's different on the left down at the bottom is that the pressure is coming up from the center, and when it's off, it's blocking the fluid. And then when the computer energizes the solenoid and pushes the check ball in the snout off the seat, we're able to flow oil to the bypass valve. Here's some main control valve identification. Like I said, there's not a top and a bottom or an upper and lower to this valve body. The two halves are, one half is called the main control valve, the other is the solenoid body. So we can see on the right in the chart that we've got the spring dimensions here for you guys. Well, those are the spring measurements that I took off of this valve body. That this is a brand new valve body, so this is a comparison only. Yours may vary slightly, but moreover for broken or really collapsed springs, that's what these measurements are all about. And also, the number 2 here, the solenoid pressure regulator valve, we're going to talk quite a bit about here. Well, that is the equivalent to the actuator feed limit valve on GM vehicles. The GM, it's called the actuator feed limit valve. On all Fords, it's called the solenoid pressure regulator valve, and it does exactly the same thing on both the Ford and GM. That is control pressure. It regulates line pressure to the solenoids. The solenoid body valves, mix and match them. All 3 valves are identical. All 3 springs are identical as well. We have some small parts for you. In the solenoid body side, we just have one small filter. Good news is that it's open at both ends, so it doesn't care which way it goes into the solenoid body. Here's our main control small parts. We've got 3 check balls and an accumulator and spring. Pretty straightforward. It's really simple. There's 3 pockets. Takes 3 check balls. There's no variations in the check balls. Okay, some valve body issues. Well, we may have a unit that comes into your shop with a P0735 or a P0767 or a P02704. We've got the 5th gear ratio, shift solenoid D stuck on, and the 2704 is the overdrive clutch system fault. The 2700 codes are all clutch system faults. Starting at 2700, 1, 2, 3, 4, 5 are all clutch system faults. Well, early on, these units, they just were having big-time valve problems to begin with. Well, what they did at first was they were reprogramming controllers for units with less than 6,500 miles on them, and that didn't change it. It didn't help. They were still wearing out. What's happening is that you can see down here the valve at the bottom, the black line is line pressure, and this feeds up to the shift solenoids which regulate the clutch valves and the latch valves. Well, what happens is that these valves, these glands and the bores start wearing out so much that they lose pressure to these solenoids. And this has been a bit difficult here. Let me show you some symptoms. I put a video up for you guys, and it's really choppy. We're gonna run through it here. As best we can. This is a 4-cylinder Fusion. Look at this. You can't. It's so choppy that you can't see it shake as badly as it does. This thing shakes violently, and here the guy goes around to show the tailpipe, and it shakes. You can see it a little bit better when he comes around to the driver's side here on the screen. You can see it. It's basically like showing it shaking in slow motion. So what I want you to do, grab a pencil and write this down. This is, I want you to go to YouTube and put in Ford Fusion common transmission problem. Ford Fusion common transmission problem, and this video will come up. And you'll see how violently the engine shakes. And also try, what I want you to put in is 6F 35N shakes. And you'll get a Mariner, you'll get a Mercury Mariner doing exactly the same thing, except to a lesser degree. So what's happening here is that when this valve wears out, the solenoid regulator valve wears out over here, we have a loss to this pressure going to the solenoid, that we're losing pressure to the solenoid feed. So we're going to use the shift solenoid A as the example, controls the 1, 2, 3, 4 clutch, or the forward clutch, and this sends oil down to the 1, 2, 3, 4 clutch regulating valve and the clutch latch valve. Well, if the pressure is so low, what happens is that it's unable to keep the clutch regulator valve in the shifted position, because the latch valve and the regulator valve use the pressure from this solenoid to move the valve so that line pressure goes to the clutch. That's all that happens. The shift valve pulse widths on these two valves regulates line pressure to the clutch and has the apply. So this is why it's so critical to have this solenoid regulator valve in good shape. So that's Ford Fusion common transmission problem on YouTube. Check it out after the show. All right, so this is the valve we're talking about. Very critical. Then here's what they did to try and correct this. In 2012, they came out with a larger middle land. You can see it up here, and they nickel plated the valve to resist wear on both the valve and the bore. You can see the old one is Teflon coated and it has a short middle land. Also, they took the casting around 2012. This casting on the left, you can see that it's open, but this casting is covered by the separator plate and is a blind casting. So what they did on the right, in the circled area on the right, was to fill in that area so that where the middle land was longer, with the middle land longer, more bore, we are now able to support the to support the valve and get some better longevity out of this setup. Now, there's a couple of ways that we can inspect the bore. I mean, besides shining a flashlight down there and sticking your eyeballs on it, we would like to have some measurable results here. We can use a hole gauge down into the furthest land. That's right here. And we're going to get it so it touches the outer surfaces of the innermost bore and get our caliper on this and measure it out. The caliper on the left's been zeroed out. Now we get to the valve. We show minus 9,000. That's 9 thousandths of clearance on that valve. Way too much. This thing is ready to go. We did that on the next land out, and on that partition, we found 4 thousandths worth of wear. So this valve was leaking all over the place, up one side and down the other. The other way we can check them is with our vacuum tester. Can you use a late Ivan says, can you use a late 2012 valve body on an early transmission? And the answer is absolutely. That is the direct replacement for the early transmission. That will transfer to all years and all models, Ivan. That's a great question. Thank you very much. Let's see. Oh, vacuum testing. We can test this circled area and listen for leaks at the arrowed area. We should hold 16 inches of vacuum there. And I'm guessing the majority of them won't because they're all gone. All gone. So let's see here. So what's the solution? Well, there's a couple of different options. One is to replace the main control valve body with the part number listed at the left of your screen. That is the most updated part for this fix. This supersedes any other published number. It should work at your Ford dealership. I don't know. Here in the United States, a guy this morning I did this, and while I was doing the show, he called his dealership, and here in the United States, that main control valve body is $82. I don't know what that would be Australian, but it's pretty reasonable. The aftermarket does make upgrades for this valve. I didn't research the cost on those. I know some of that stuff can get pretty spendy. So a late model valve body would be the way to go as a solid fix for this one. And for our 82 bucks, I think that that would be prudent to do it every time. Okay, so moving right along, that's the valve body. So we've got line pressure taps here for you, for your diagnostic pleasure. We've got the main line pressure, the 456, the 3.5 reverse clutch that we can check. Also, cooler return and compensator feed. On the left, we've got our chart, 50 to 55 park and all the other ranges except reverse, which is 9100, or I don't know if I should use the metric system for you guys, but 340 to 380 kilopascals, KPAs, and wide open throttle. You can see that park and neutral, same 340 to 380 KPAs, and reverse at wide open 18 to 2 grand KPA. And the same, you'll notice that all the wide open throttles are the same and all the minimums are the same. And this brings me to checking line pressure on vehicles these days. Not only do we want to know, how is it working? Okay, is it starting at 55 and we mash the throttle? Is it going 270? Or the equivalent KPAs. I'm going to use the PSI numbers because I've been doing it all morning. Anyways, so what I want to see is how is the behavior of the line pressure rise circuit. Okay, because typically the reason we put a gauge on there is to see we either have soft shifts or hard shifts, right? So if we have soft shifts, we want to know, is the pressure rising? If we have hard shifts, we want to know, is it maintaining a lower pressure? Well, these days, in the past, you know, when you call into the tech line, or when a tech calls into the tech line, I almost always will ask, okay, what's line pressure doing? And so most times guys are prepared for that. But what they're not prepared is they're not prepared for the question, okay, so you've got low line pressure, okay, you got high line pressure. What is the line pressure being commanded to do by the scan tool? So not anymore do I just want the technician with the pressure gauge. You know, oftentimes he'll sit in the cab of the truck or the car or whatever and have the pressure gauge in his hand and the phone in his other hand and tell me about line pressure. Great, that's cool. But anymore, what I want the technician to do is to have not only the pressure gauge and the telephone there, but I want him to have the scan tool there as well. Because if it's low or it's high or it's not rising up and down like it should, the next question is automatically, what is the computer commanding line pressure to do? So that leads us to our next page, is if we have the scan tool there, if we have the pressure gauge there, and our scan tool there at the same time, we can watch right here in the middle of the page, we can watch line pressure control amperage. Amperage high, approximately 1.0 at idle, pressure low. Amperage low, pressure high. That's simple to remember. When I'm talking amperage low, you'd be lucky to get 0.2 amps, 0.2 of an amp at wide open throttle in the bay, in the service bay, because if the thing hooked up, we won't be able to hold the wheels on the ground. You could probably stab it up in the air and watch it that way, but it's very critical to the behavior. Say the line pressure is really high, but yet the amperage shows 1.0 and dropping at 1.0, you know, it's at 1.0 and then it drops to 0.2, or it varies when we start manipulating the gas. Things get kind of fishy right there because, oh look, the computer's commanding it correctly, but the transmission is clearly not listening because it's at full line pressure. So there's a couple of things with that. There's a solenoid, which most guys would go and change, or at least maybe trade one solenoid to the other quickly. Or what there is to do is get out your inductive amp meter gauge to see if the amps are truly flowing through to the transmission, because if you get an inductive meter reading on there that coincides with what you have on your scan tool, then you know this is an internal problem all the way. So that's how we're going to work that amps scan tool in concert when we are checking line pressure. Okay, so the other thing that we're going to use our scan tool for is down here on these last four or five readings where we've got amps showing for A, B, C, and D, controlling the clutches. For example, if shift solenoid C and B are working on the 2-3 shift, if the 1-2 shift was on time, but the 2-3 shift didn't happen. Well, what's the scan tool commanding? Is the scan tool commanding the shift and then the shift not happening? Well, where you're going to find that is right here, that if we want to, if as the 2-3 shift happens, this changes and this changes simultaneously as the shift occurs. Now, if that happens and the shift doesn't happen, we're pretty solid that we're going to have a valve body issue. So this is a quick way that we can use the scan tool to see if it's being commanded to shift when it's supposed to. And these are all questions that I would ask you if we call in and talked about the way the car worked. And here on this next page, the thing we want to note over on the right is that all those squares that say pressure, pressure, all the way from the start to the bottom, are just calculated values. There are no pressure sensors on this valve body, so it figures through the amperage that it's sending out what the calculated value should be for those for that particular reading. If you wanted to see the pressures change when the shifts are commanded, I suppose you could look at it that way. That's another way to look at it. So that's just another tool, but know that they're not pressures, they're just calculated values. Lastly, on the PIDs, you've got a P0740, and this holds true for many Ford products. You've always wanted to look at TCC slip ACT, which is the difference between the engine speed and the engine RPM and the turbine speed RPM. If you're setting a 740 or the customer comes in with a 740, what we do is we record the code, and then we take the car out and watch that RPM rating right there. You'll see back here, there's the solenoid command. You could toggle between these two. Here's the TCC amperage. The amperage goes down. You see that start working. Then you flip to the next screen and watch what RPM's doing. You could probably get these on the same screen. And oh, look, it's being commanded, but RPM does or does not change. So that's really the easy diagnostic tip for the P0740. And lastly today, we've got the driver side axle lead. This is super common on these units. Early on, these little skinny bushings that we see here on the left were just not supporting the axles. And the inferior bushing and clearance specification, it just wiped out the bushing prematurely, and it started to let the axle really hammer the seal. So we were able to, what we needed to do was change it. Well, Superior products design a bushing that is wider. That's the bushing on the right, you see. And it has a notch there because the thinner bushing was just wide enough so that the oil hole, the lube hole, would be exposed. What Superior did was they made a wider bushing and put a cutout for that lube hole. Of course, there's a more durable material, and the tolerances are much tighter on the aftermarket bushing. So what they did was they came up with a tool. They fabricated a tool to pull the bushing out. Looks kind of like the old extension housing bushing remover tools from back in the day. And also what they did was pretty neat. They added the driver over here on the lower right-hand corner that just screws on, and the bushing fits real snug here, and we drive the notch. The notch goes up about this area in this bore. There's a position marks on the driver, and then we can flip this driver around and use it to install the axle seals. It's a really slick setup. A note of warning that these are U.S.-made bushings here in this kit. Excuse me. There's been some overseas bushings that we've seen come into the country that are not within specs. They're not holding their specs as to tolerances like these are, and may have premature failures. So be very aware if you use this tool and you're using up your bushings, make sure you get those bushings from the United States. Okay, I got to run over a little bit there because you're the last show of the day. If you did not receive your PDF, you guys have, I don't see anybody that talked about that. This is where you get it on your email. You click here for the PDF. Also, you can register for your time zone, and then here's how you can invite a friend. So, while I'm getting ready to sign off here and call out our suppliers, if you have any further questions, now would be the time to type those in. First of all, I'd like to thank the continued support of our sponsors, Seal Aftermarket Products, TTK Max, Whatever It Takes, Transmission Parts, Raybestos, Seal Aftermarket, Hyper Blue, Performance Pistons, Volt Electronics, Transtech, and Toledo Transkit. Are there any further questions? Well, then I would like to thank you all for getting up this morning and sharing some coffee with me. I hope you guys have a great rest of the day. My name's Bill Brayton on behalf of ATRA. Make it a great day. Thank you.